Welcome to section 4.4, write linear equations in standard form. Now, standard form, I will say, is pretty much the least useful form of a line that we have. Because unlike point slope form, unlike slope intercept form, standard form alone doesn't give us a lot of information. It just doesn't. Because standard form says that every line is equal to some number a of x's plus some number b of y's, and that's going to equal some number c. Those numbers a, b, and c have no actual meaning according to the graph, like our letters meant in slope-intercept or point-slope form. However, what's nice with this form is because they don't actually have any meaning like that, we can actually write our equation of lines in very different ways. So for example, when we have this equation of a line, 2x minus 6y equals 4, we can write other equations in standard form that are equivalent to the same line. And you can do that using various algebra things that we have done for a while, namely multiplying or dividing numbers to both sides of the equations. So we could divide both sides by 2. I'm going to come out with a 1x minus 3y equals 2. That equation is equivalent. We could also multiply it by 2. So 2x times 2 would get us to a 4x, 6y times 2 would get us to a 12y, and 4 times 2 gets us to 8. That would also be equivalent. Or you could multiply by 3 and divide by 2. Like, you don't have to just multiply or divide by whole numbers, you can do fractions as well. So 2 times 3 is 6, divided by 2 would give us 3. So you could have a 3x minus 6 times 3 is 18, divided by 2 is 9, so 9y, and 4 times 3 is 12, divided by 2 is 6. So I've now got 3 different options of what we could have done for an equivalent equation. That's okay. That's one of the only nice things about standard form. Now, if we want to find an equation in standard form for a line, my suggestion is get it into another form first. Go for either slope-intercept or point-slope. And then you will want to rearrange it to get it into standard form. So let me show you with this line, one of each. So let's start out with this one. We'll go point-slope. So for this slope, we're going to go down 1, 2, 3, right 1. So a slope is down 3, right 1, or a slope of -3. We can also use our point of 1, 1. So we have a y minus 1 equals -3, x minus 1. And that would have been it for if we were just going for point slope form. But we now need to get this into standard form. So in order to do that, first thing we have to do is distribute that -3 into both sides. So we have a y minus 1 equals -3x plus 3. And standard form gets all of our x's and y's onto one side. So I'm going to add my 3x to get that over to the other side. So I'll have a 3x plus y, oops, that's an x, plus y, minus 1 equals 3. Now we just need to get that minus 1 over to the other side. So all that's left is just our number of x's and y's on one side. So we can now just add 1 to both sides, and we'll come out with a 3x plus y equals 4. And that's your equation in standard form of that line. Now, if I want to get that into slope-intercept form, again, we have our slope, so we can do a y equals -3x plus b. Again, we have another point, so we can go and erase those y's and x's and replace them with a point that we're substituting in. So that's going to be a 1 and a 1. So -3 times 1 is -3 plus b equals 1. We can then add +3 to both sides, which will get us a 4 equals b. And now we can have it in slope-intercept form of y equals -3x plus 4. Now, we still want to get all of our x's and y's onto the same side, so we can go ahead and add 3x to both sides, and we'll be left with a 3x plus y equals 4. Well, by golly, that's the same answer that we got for the other way. So good news, we got the right answer, but both ways are going to just take a little bit more work. So if you like the distributive property step, I'd suggest going down the point slope form path. If you like not having to distribute in, I'd suggest going down the slope intercept form path. But either way, you need to get it into standard form for this section. And just like I promised earlier, we are now back to vertical and horizontal lines. So we now need to write the equation for our blue line, that horizontal line down there. Well, what do we know about the points on that line? Well, this value right here has an x-coordinate of 2 and a y-coordinate of -4. This point right here is going to have an x-coordinate of 0 and a y value of -4. So which number is it that really matters or doesn't change? It's that -4 doesn't change no matter where on that line you're at. So your equation for your blue line is y equals -4. Same thing with your red line. We know that our x is 4, our y is 1. Well, now if we pick this point on the line, our x is 4 and our y is 0. The 4 is the number that doesn't change in this case. So that means for the vertical line, it's all about those x coordinates, and our x has to equal 4. So if you have to find equations of vertical or horizontal lines, that's all you got to do. Now let's go and do one more problem solving question. So we have a line and it goes through this point. We need to solve for a, or in other words, what is that missing coefficient in our standard form equation? Well, just like when we were trying to solve for stuff earlier, we have a point and that gives us an x and a y coordinate. So we can go and plug this number in for x, this number in for y, and what's left is the a that we're trying to solve for. So we'll have an a times -1 plus 3 times 0 equals 2. Well, 3 times 0, that's 0, so that cancels out because we add 0. And if we add 0, nothing changes. So what's left then is a -1 times a equals 2. We can now divide both sides by -1, and we'll be left with then an a equals -2. It didn't ask us to rewrite our equation, it just asked us to solve for a, which we've now done. So that's all the more there is to it. And that's going to be it for this lesson. So as always, if you have any questions, let me know, and otherwise, good luck.